Hello everyone. In this video, I will give you a trick on how to write graphing form given the parent equation. I have here a 4-column table. The first column would be on the family of a function. The second column would be the parent graph. The third column is the parent equation. And the fourth column is a blank, which we are going to fill it in today. The graphing form of each of these family of functions. So let's start first with line. So this is the parent graph of a line and this is the parent equation of a line. Now the graphing form of a line would be y equals a parentheses x minus h plus k. So this is the graphing form of the line. Now the second one right here is quadratic equation, and this is the shape of the parent graph of a quadratic graph, which is like a letter U, and this is the parent equation, y equals x squared. Now the graphing form for this quadratic equation would be y equals a x minus h squared plus k. Now from here, I'm sure others have seen the pattern already. If you recall, h is the parameter that translates the graph left or right, and k is the parameter that translates the graph up or down. So since we say h is left or right, and we say x-axis is actually left or right, positive x is directed to the right and negative x is directed to the left. So that means these two would go together. Now the k here is just by itself. Now the same thing for this. As you can see, h goes with x and then the k is by itself. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So this is absolute value function here. This is the parent graph. It's like a letter V. This is the parent equation. Again, remember the h goes with the x. So then we can go ahead and write y equals, there's always going to be a in front, which is the vertical stretch. So that would be a absolute value of x minus h plus k. And then we have a cubic here. So a cubic function, the graph of a cubic function looks like this. So one end goes up and then the other one goes down. And then this is the parent equation. It's pretty much the same thing. Y is equal to, we write the a. And then that would be parentheses x minus h cubed plus k. So pretty much the same thing as what we did on the first two examples. The h go with the x, the h go with the x, and then the k is by itself. Did you get the same answer as this? Good. Perfect. Now let's move on to the next one right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So square root function. This is the vertex of the square root function. And this is at the same time the end point. So it's directed to the right. And this is the parent equation. And so we can go ahead and write the graphing form for this. Y is equal to a square root of, that's going to be x will be paired up with h. So that would be x minus h. And then the k will be outside of the square root plus k. Now the next one right here is cube root. So this is the locator point or the vertex of the cube root. And one end is directed to the right and the other end is directed to the left. So to find, to write the graphing form of a cube root function here, that would be y equals a. That's the cube root of, that's going to be x. Remember, h goes with x. So that's going to be x minus h. And then plus k. Did you get the same answer as this? Good. Perfect. Now let's move on to the next one right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here, reciprocal function. So that is, it's like a hyperbola function, and this is the locator point. So this is the parent equation of a reciprocal function. And so to write the graphing form for this, that would be y is equal to 1 over. Again, h goes with x since h translates the graph left or right. So that would be x minus h and then plus k. So that's the graphing form of a reciprocal function. Now let's have the exponential right here. Exponential, this b stands for the base. So then again, remember h goes with x. So this would be y is equal to a, and then we have a b parentheses x minus h plus k. So this is the graphing form of an exponential function. Again, in order that we can write the graphing form of any equation, if we're given the parent equation, is that we always remember that the h will always go with the x, and you can put them in parentheses. That's x minus h, and then put the k by itself. So the reason why h go with the x, it's because remember, h translates the graph left or right, and so x is actually x-axis is actually positive on the right and negative on the left. So they go together. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!